Hey, Algebra 2, welcome to lesson 53. Guys, I'm going to be honest with you. I have no idea why I only gave you one lesson today and didn't give you two. But, congratulations! You only have one lesson today. Okay, here we go. Look at example 1. We're talking about just conversions again. So it's stuff that you already should know. And then, we go into more conversions and we go into chemical stuff that we were working with the other day. So let's do it. 7,560 centimeters into kilometers. So we're going to go 7,560 centimeters, put centimeters on the bottom. I don't know how many centimeters are in a kilometer, but I do know that there's 100 centimeters in 1 meter. And then after I get rid of the centimeters, I can now get rid of the meters. Okay, so I need kilometers. I put meters on the bottom because it's right here. So to cancel out, if it's on the top, I need to put it on the bottom. So cancel, cancel. We're left with kilometers. How many meters are in a kilometer? 1,000. Okay, so what do we have as our answer? 7,560 over 100 times 1,000 kilometers. Okay, I love crossing out my units because then you know that you're left with the unit that you actually need, okay? And then you can solve it or you can just leave it like that. It doesn't matter to me because in the book, they change it every 5 seconds, whether or not they want you to solve it or just put your answer, just put your numbers in a fraction like that, etc., etc. Okay? Here we go. Look at example 2. You're doing 15,740,000. Be careful on this, square centimeters. When I do square centimeters, I go centimeters times centimeters because square means that there's 2 centimeter units, okay? And then we want to get it to square kilometers. That's kilometer times kilometer, but I have to put it like this because it's the answer, okay? So that means we need to eliminate 2 centimeters to get 2 kilometers. And you're like, what are you talking about, Miss? Let's go watch. You have to put 15,740,000 centimeter over, then we're gonna do the exact same process that we just did to get to centimeters to kilometers, but this time it's double because you're canceling 2 centimeters to get 2 kilometers. So I go centimeters to meters first, 100 over 1 over 100. That means I can only cancel 1 of my centimeters, so I have to do that again. 1 meter, 100 centimeters. Now I can cancel, cancel, cancel my centimeters and I'm left with meters. I'm gonna go down here. I don't wanna be left with meters, I wanna be left with kilometers. So I'm gonna go 1,000 meters. Cancel 1 of my meters, but I'm still left with another one, so I have to go meters again. Cancel, cancel. So now what's my answer? 15,740,000 over 100 squared, I'm going to put, there's 2 of them right here, and 1,000 squared. And that is your answer. Okay? Look at example 3. They're saying the only difference between examples 1 and 2 and then example 3 is that example 3 is using English measures. Okay, which really doesn't mean a lot to us. It's just that English measures aren't used very much in science. They're not really used very much in Honduras at all. They're only used in the United States. But we're going 32 yards into meters. So this will be a fun one because look, if you're going to think about how are you going to get from yards to meters, oh, it's going to be cute, you guys. You have to go from yards to feet, feet to inches, inches to centimeters, centimeters to meters. Woo! Okay, so I'm going to start all the way over here. So I have room 32 yards. Yards on the bottom. Feet on the top. There's 3 feet and 1 yard. Cancel, cancel. Now I need to cancel my feet to get to inches. So there's inches on top, feet on the bottom. There's 12 inches, 1 foot. Cancel, cancel. Okay, now I need to get rid of inches. Inches on the bottom, centimeters on top. There's 2.5 centimeters, 2.54 centimeters over 1 inch. Cancel, cancel. Now we have centimeters and we need to get to meters. Centimeters on the bottom, meters on the top. Cancel the centimeters, and we're left with 100 centimeters and 1 meter. So our answer is going to be 32 times 3 times 12 times 2.54 over 100. And then you check your units and you know that you got it right. Okay, example 4. Where did I just put my eraser? Ah, I just had it. Oh, right here. Okay. Okay, example 4 is one more with double units, but in English measures. 0.042 square square kilometers. So I'm going to put kilometer, 2 miles. Square miles, right? Yep, square miles. Oops, my answer starts with square. Okay, here we go. 0.042 kilometer times kilometer. To get to miles, we're gonna have to go a long way. We're gonna have to go kilometer, meter, centimeter, inch, foot, yard, no, foot, mile. We can do foot, mile. Okay? That's the only way I know how to do it, you guys. If you find out a different way, great. Just make sure that you're using the right conversions. So I put kilometer right here, 2 times to cancel it, I'm moving it to meters. It's 1,000 meters and 1 kilometer. Cancel my kilometers. Now I need to cancel my meters with centimeters. Centimeter, oops, we need to cancel meters, so you put that on the bottom. Centimeters. There are 100 centimeters and 1 meter. We cancel our meters. And we're left with centimeters. Now we need to cancel our centimeters into inches. Centimeters on the bottom because it's on the top there. And we want inches. Okay, 1 inch, 2.54 centimeters. Cancel your centimeters, you're left with inches. Now we need to go to feet. Woo! Inches on the bottom because we need to cancel it. Feet on top. There are 12 inches in 1 foot. Make sure that you don't put 12 feet in 1 inch. Make sure you're not mixing up your measurements. Cancel. Then we need to convert it into miles. Feet on the bottom. Miles on top. There are 5,280 feet in 1 mile. 5,280 feet in 1 mile. Cancel out my feet. You're left with square miles. So your answer, as there's no room to write it, so I'm just going to tell it to you verbally, is 0.042 times 1,000 times 1,000 times 100 times 100 divided by 2.54 times 2.54 times 12 times 12 times 5,280 times 5,280. Whoa, that is a crazy one, okay? Look at example 5 to learn how to do percentage by weight on a chemical formula. Okay, look at what it's asking you in example 5. It says, what percent by weight of Na2S2O3 is sodium? Sodium is Na, it says right there in the parentheses. So they want to know what is the weight in percent, or the percent in weight of the sodium part of this molecule, okay, of this compound. So, what the information they're going to give you is this. What's the compound and what are the weights? What does that mean? The compound is how many atoms of Na are there, how many atoms of sulfur are there, how many atoms of oxygen are there, right? That's the compound. Now over here is going to tell you the atomic weight of each one of them. So sodium weighs 23, sulfur weighs 32, and oxygen weighs 16. Okay guys, what does that mean? That means that if you have Na2S2O3, then look what you're going to have. Na is going to be 23 times 2 atoms, so that's 46. Sulfur, there's 2 of them, and it weighs 32, so it's 32 times 2, 64. Oxygen, there's 3 of them, and each one of them weighs 16, so now you have 48. So your whole compound weighs 46 plus 64 plus 48 grams. Add that together and you're gonna get 150 grams is the weight of this compound, okay? So if they wanna know what is the weight percentage of sodium, all you're gonna have to do is go 46 divided by 158. When you do 46 divided by 158, you're gonna get 0.29. Move your decimal place 2 places, and you get 29%, okay? If you don't like this whole like divide to get your percentages, which I would beg you to try to learn, you can always do this. I'm trying to think. X percent of 158 equals 46? And you're gonna end up getting the same thing, that is 29%. Okay, but again, the process is, this is how many atoms you have, this is the weight. You multiply those to find your total weight, and then you divide the one that you need to get the percentage. You have to do this step, guys, even though you only need one of them, because if you don't, you're not gonna know the total, okay? Go ahead and try your practice, and then I'll come back and tell you if you got them right. Okay, the answer to letter A is 8%, or I got like 7.8%. So in case you didn't know how to do it, there's only 1 carbon and 4 chlorine. The carbon weighs 12 and the chlorine weighs 35. So you have to do, 12 is normal because there's only one of them, but then you do 35 times 4 is 140. When you add these two together, you get 152 grams in total is the weight of your compound. Then you do, they want carbon, so it's 12 divided by 152, and then you have to move your decimal place to get 8%, or 7.8, and then round. I'm not gonna actually do letter B for you, but I'm gonna read off what it is the answer, and read off the steps to the conversions. Then all you have to do is go and make sure that you use those steps and make sure that you canceled out and didn't put the wrong thing, like 3 yards and a foot or something like that, like something mixed up, or that you didn't cancel your units correctly. But let me know if you didn't understand it. Just send me a picture and say, I don't know where I went wrong. Your answer is 0.073 times 1,000 times 1,000 times 100 times 100 over 2.54 times 2.54 times 5,280 times 5,280 times 12 times 12. There you go. Let me know if you guys need any help. Enjoy your one lesson. You're going to be seeing a lot of that in the next couple of weeks as well, as we have some graduates, hopefully, right, starting your trabajo social. Woohoo!